Welcome. Today we're going to be taking a look at the notes worksheet entitled Half Angle Formulas. And so this would be the last batch that we're going to really take a look at here. We've been doing combination angles basically and looking at all the trig ratios of those new angles. We did it with addition and subtraction. Remember the sum and difference formulas. We did it with the doubling, so the double angle formulas. And now everybody, we're going to do it with halving our original angles. So taking whatever our original angle is, dividing it by 2, and then looking at the trigonometric ratios, specifically the primary ones, sine, cosine, and tangent. So what I'm going to do is just give you the formulas initially, lay out a couple ideas behind it, and we'll take a look at sort of one quick proof as to where it came from, and then go from there, do the problem solving that goes with something like this. So everyone, if you would, let's go ahead and fill these in. These are the last that you're going to need to know for this section, the sum and difference, the doubles, and now the halves. So this one has a plus or a minus out in front. We'll talk about that piece. And the good news is it actually only uses one of the primary ratios. So we only use the cosine of the original angle for all three of these, as a matter of fact. So as long as I know the cosine ratio of the original angle, that'll allow me to get the sine ratio of the half. Okay, the next one, very, very similar. That's the good news with it. It's just a plus instead of a minus. Okay, so 1 plus cosine of x over 2, and then the positive or the negative root. We'll talk about that piece in just a sec. Now the tangent one is basically just taking these two and dividing them. We'll probably even make it a little easier. So I guess in terms of the memorization, sine and cosine you really have to know. Tangent we can work around. But if you did kind of play around with these two pieces and did this divided by this, it does give you this right here as the 2's would cancel out. Okay, good. Those are your three. These two, yes, you definitely have to really learn, memorize, whatever the case may be. Tangent, I'll let you work around a little bit. There's a blank on your paper, everybody, that we're going to need to fill in, and then a couple other ideas as well, and then we'll go forward from there. So that sign is the key. That sign, the plus or the minus, is really based on the quadrant. Of our half angle. So please write that in there if you get an opportunity. And then I'm just trying to think back to the previous lessons. If you remember the way we did this, everybody, you would find the ratios first, and then at the end I would ask you, hey, by the way, what would be the quadrant of our new angle? Now in this case you have to reverse it. You're going to need to know the quadrant of our new angle before getting the ratios. That is the main difference between the halves and the others. So we're going to need to figure out the quadrant first, then go from there. So what I'm going to do is just give you a little rule of thumb for what would be considered our primary rotation right here. And this might not work for every single problem we do, but really it should work for the most part. So again, it's just a rule of thumb. Here's the way I'm going to do it. I'm going to write it right up here. This would be the quadrants, and I'm just going to write for the primary rotation, just between 0 and 2 pi, or 0 and 360 degrees. If we encounter angles outside that primary rotation, either clockwise or more than one, which is certainly feasible, these nice rules of thumb don't quite apply, but I still think it has merit. So anyway, here's what I'm going to do, just kind of write some things. If we know the original angle, then where is the half angle going to be? That's, I guess, what I'm after in this case. And so let's just run the 4 quadrants down. And again, for the most part, we will utilize exactly this idea. And if for whatever reason something changes along the way, we'll deal with it independently. So I guess I would ask you this. If your original angle is in quadrant 1, so between 0 and 90 degrees, so pick any number between 0 and 90 degrees and take half of it. And what quadrant would that new angle be in? And I'm hoping you would realize, like if I take 60 degrees and take half of that, it's 30 degrees, which is in quadrant 1. So if it was in 1, it stays in 1. All right, everybody, quadrant 2. If the angle's in quadrant 2, so pick any number between 90 and 180. It'll work for any, I promise. Pick any number between 90 and 180 and take half of it. And where does it end up? So I'm just going to pick 100 degrees. Half of 100 is 50. And as a matter of fact, if you picked any quadrant 2 angle on that primary rotation, it would end up back in quadrant 1. Good. How about quadrant 3 now? Quadrant 3 angle. Pick any number between 180 and 270. Any number at all. And when you take that number between 180 and 270, take half of it, where does it end up? And if I'm going to pick 200, that's easy for me. If I take half of 200, it's 100, which is in quadrant 2. And in the last one, everybody, quadrant 4. Let's run this rule. So if it's in quadrant 4, pick a number between 270 and 360, and then take half of it. Where would you end up? I'm going to go 300 degrees this time. 300 divided by 2 is 150. I'm in quadrant 2. So you can kind of see, all right, if I started here, I end up in quadrant 1. If I started here, I end up in quadrant 2. And we'll go with that for the most part. As I said, it's not a cure-all, be-all, but it's pretty good for what we're after. Okay. We'd love to just show you maybe like where this comes from. Especially this one's quite a bit different than the others, of course. You've got a root in there. You have the plus or minus. The easiest one to just take a look at is that middle one. So if you don't mind, I'm going to do that one. So cosine of the half angle. And it actually comes from the double. That's why these lessons pretty much are taught back to back. They're intertwined. So does everyone remember this formula that I gave you on the previous notes worksheet? Remember, cosine of 2x has 3 variations. This is just one of them, of course, but it's perfect for us, our purposes here. And this mathematical statement is true as long as this number is double this number. And so what that means, and I just wrote this on your paper, what I can do is just substitute any 2 values where this is double this. And you can see that. If I start out here and double it, that's what I get. And so this relationship is true. Now what I want to do is actually see what that means in terms of cosine of x over 2. So as it says on your paper, now solve for cosine of x over 2. So I'm going to do that right off to the side. And again, just one more time, in terms of this formula right here, as long as this is double this, this equation works. And so now, let's see, 2 cosine squared of x minus 1. Oops, sorry, x over 2, my fault. And let's go ahead and solve for the cosine of x over 2. Everybody add 1, and I get the 1 plus cosine of x. 2 cosine squared, let me do a little better job on that, x over 2. Everybody divide by 2 on your paper. And so I divide by 2. You can see that obviously start to really work out nicely. Okay, good. And how do I undo that square? Let's root both sides, everybody. So square root. When I square root the right-hand side there, I do just get my cosine of x over 2. And remember, everybody, when you undo a sign, officially you're supposed to take the plus or minus of the root. And so there's where it is. And so again, this one is a little more unique compared to the others, but you at least see, I'm hoping, where that came from. It comes from the double angle formula of cosine. Okay, nicely done. Well, let's do again just a few problems together. Examples 1 and 2 go hand in hand, and an example 3 is just like some of the others we've been looking at in this unit. So everybody, it says use a half angle formula to find the exact value of cosine of 15 degrees. So 15 degrees is half of an angle that we already know our trig information on. Of course, it's half of 30. So what I'm going to do off to the side here, everybody, is write cosine of 15 degrees is equal to the cosine of really, as a half, is 30 degrees over 2. So if the original angle is 30 degrees, then 15 degrees, of course, is half of that. And so it's a half angle formula that we're going to use. And so if you look at the top of your page, this would be the middle one. I want the cosine of 30 over 2. Now, before we even start putting my root and the numbers in place, I do need to decide one thing first. Is the cosine of 15 degrees positive or negative? So I come back to this piece right here. Is our half angle positive, or I should say, is the cosine ratio of our half angle positive or negative? Well, I think we all know in quadrant 1, it should be positive. Cosine's positive in quadrant 1. So it's the positive root. So positive out in front of the root. And then very simply, I'm going to do 1, and then it's plus the cosine of 30 degrees divided by 2. So 1 plus cosine of the original angle divided by 2. Now it just so happens, again, we know that one. Cosine of 30 degrees is square root of 3 over 2. So I have that piece right there. Now I've seen students over the years do a couple things with this. I like putting it over 1. You don't have to if you don't want to. But what I saw is a fraction within a fraction. And by the way, this is all under the root. I should be very clear on that. And I guess I would ask us to clean out the denominator here, especially the 2. And so if you remember the way we've done this before, and we've been doing this for a while, I'm going to multiply everything by 2 to get rid of that denominator of 2 right here. And so when I do that, everybody, I get 2 times 1, which is 2. No need to cancel anything. 2 times root 3 over 2. 2's cancel. So I get square root of 3. Then in the denominator, 2 times 2 is 4. And that is all still under the root. Nicely done. I think this looks good. I mean, it's a nice expression. I would argue we can probably go a little further, just a touch. And if you look, the top, well, that's messy and ugly, but that's as good as it's going to get, I think. But the bottom, everybody, what is the square root of 4? And the square root of 4, just as an integer, is 2. So in reality, guys, that is the final answer. The cosine of 15 degrees is that. Interesting. Okay, I'm going to box that up, and then let's see what else is written here, and then give it a try. So it says, in a previous lesson, we found the value of cosine 15 degrees using a sum/difference formula. I think we did a difference formula on it. We obtained a value of this. This was the cosine of 15 degrees. Is this the same as your answer from example 1? Okay, there's only one way to find out. Let's bring that calculator up, everyone. And when I do this, let's clear that stuff out. Cosine of 15 degrees as the decimal approximation is that. And if you remember, actually, you know what? Let's go back for a sec. If you remember, I did this root 6 plus root 2 and then divided by 4, same number, absolutely. And that's what we did using a difference formula, and it worked great. You know, no problems at all. Is this the exact same ratio? Well, let's find out. Let's see. So I'm going to do, well, let's get parentheses, I guess. Big square root here, 2 plus square root of 3. Oops. Go on back there, close that on off, and then get that for that one. And how about one more? Let's see if I have enough decimals, or I'm sorry, parentheses on that. And look, there it is. So you notice that number is the exact same, just a different way to represent it, of course. So is it the same? Yeah, sure. It definitely is. I like the difference formula better, to be honest. I think it's a little quicker and cleaner. But yeah, I mean, 15 degrees is half of 30, so theoretically it works. All right, let's do one more here. Same situation. Looks like I have cosine of 112.5. All right, so kind of random here, but it definitely is a half angle of something we know, so we're going to utilize it. All right, first order of business, everybody. When I do the cosine of 112.5, it's in the second quadrant. Is cosine of 112, I'm going to write that here. Is cosine of 112.5, is it going to be positive or negative? And cosine is negative in quadrant 2. So let's get that taken care of first. And then let's think about the cosine of 112.5 degrees. That's what I want. And in terms of this lesson, I'm hoping you guys realize that 112.5 is really half of 225. So the original angle is something we know, 225, down in the third quadrant. And we're going to utilize that in order to get the half angle, which is, of course, this piece right here. So now here's where we want to be careful. It's still the same formula as what we used on example 1. It's the middle one from the top of your page there, everybody. But we had to decide first, do we use the positive or the negative out in front of the root? And because we know we're in quadrant 2, cosine is negative. So what we're going to have to do here, everybody, is just keep a big negative out in front of the root the whole way through. And so what this would look like is 1 plus cosine of 225 degrees over 2. Okay, good. Well, let's give it a try. Keep the negative, that's the key. And so let's see, I get 1 plus cosine of 225 down in that third quadrant. Cosine is also negative. I do this as soon as I kind of saw that fraction within the fraction. Just works for me. But let's see if we can keep simplifying here. And so I'm hoping you all see that piece, 1 plus negative root 2 over 2 over 2. And then I'm going to clean out that 2 in the denominator right here by multiplying that by 2 and multiplying this by 2. Notice, everybody, I keep the negative with me the whole way through because the cosine ratio is negative. And let's see what happens. I'm going to wait on the root for just a second. I get 2, 1 times 2, there it is. And then plus a negative, so this is going to change to a minus right there. These 2's would cancel, everybody, and I get root 2. And then over 2 times 2, which is 4. And that's what's under the root at this point. So negative 2 minus root 2, and then over 4. Okay, nice. Only one more thing to do. It's looking pretty good. I guess I would argue it's the same thing as last time around. Everybody look at the bottom when I'm talking about square roots there. I'm seeing this as, oops, let me just make sure I have that, root within a root. That's okay. And then over 2. Crazy number there, huh? But square root of 4 now is just as an integer 2, and so it comes out. So I've got a negative out in front, square root, 2 minus root 2, and then all over 2. Again, fairly contrived, obviously, but you know, working with numbers, that's definitely part of this piece. Okay, let's do one. Oh, I forgot. There's one little quick side note here, and then our last example. So as you can see, obviously these formulas are just meant to expand some of the exact values, of course, that we learned in the previous unit, the 30s, the 45s, and the 60s, and so forth. I just pasted this from what I saw online. So it just says these formulas are used along with some very complicated others, obviously, to get exact trigonometric values for a variety of angles. And so you can kind of look at, if you go online and Google it, you can find sine of 1 degree, sine of 2 degrees, and et cetera. And obviously you can see they are pretty ridiculously complex. So interesting. Alrighty, well let's bear down on what we need to do, just this example 3. So example 3, now it says let sine of theta equal negative 3/5, and the terminal side of theta is in quadrant 3. Find cosine of theta, and then, oh yeah, this is the piece right here. Okay. Now if we're going to do the half angles, which is obviously what we're going to do here, the half angles all stem from this piece. We don't even need the sine of theta, to be honest, in terms of our half angle formulas. We don't need the tangent of theta, to be honest. We need the cosine of theta. Obviously, we'll use this piece of information to get this, but this is what we need for our half angle formulas. All right, guys, draw. Absolutely. So let's make sure we're in quadrant 3 originally. So quadrant 3, and it says sine of theta is negative 3/5, maybe something like this. So negative 3 to 5. So everyone put in a negative 3 to 5. I know this is a little messy. I'm going to clean this up. Sorry, but maybe you can do it. So let's see if I can get that in a little better. So that's negative 3. That's positive 5. Okay, good. So our theta is primarily would go from here to here. Guys, if you do x squared, y squared, and r squared, just be careful on your sign. Again, if you mislabel the diagram, it's all over. So be very careful with that. Negative 4 going from here to here. Which means, of course, I am in quadrant 3, and I know cosine of theta is going to be negative in quadrant 3, and the cosine ratio for this particular theta is -4/5. So there we go. There's your theta. Okay, good. So as a result, what quadrant are we going to be in for its half angle? And this is where that front side comes into play, everybody. All you have to do is think of the rule of thumb. If I'm anywhere in quadrant 3 and I take half of it, I would end up in quadrant 2. So the theta over 2 is going to be in quadrant 2. And I'm going to put this here. That means sine is positive in quadrant 2, cosine is negative in quadrant 2, and tangent is negative in quadrant 2. So that's why we need that first. Again, the previous formulas, we did it last. Here we need it first. So we're in quadrant 2 if we take half of this angle right here. And if I'm up here, guys, for my half, sine's positive, cosine's negative, and tangent is negative. That is what we know. All right, now it's just cleanup time. Let's see if we can get this to work. All righty, guys, so sine of theta over 2. And I'm going to go ahead and use the formula here. First of all, we're in quadrant 2. So positive on the root, and it's 1 minus cosine of theta over 2. I'm just going to keep working across here. If I remember correctly, we got cosine of theta, and now I'm forgetting already. Oh, -4/5. So 1 minus -4/5, and all of that's over 2. We're going to have to clean that up, I'm afraid. So let's do that momentarily. As I can see on my board, it looks like we have the fraction within the fraction. So I am going to have to work with that piece. And if it's okay with you, rather than putting it over 1, I'm going to try to transition a little bit here. I'm thinking we're just going to multiply that by 5 and that by 5. So let's see if we can do this together. And let's just see algebraically where it leads us. There's just a lot of good algebra with these types of formulas. Okay, let's distribute. 5 times 1 is 5. Minus a negative, so I'm thinking it's going to be plus. 5 times 4/5, 5 should cancel. This cancels with that, so I get 5 plus 4. And then 2 times 5 is 10. Now I apply the root. Okay, good. And everybody, I get square root 9 over 10. And kind of thinking back to the Algebra 2 and even a little maybe in Pre-Calc 1, rationalizing denominators, I would sort of think of this as, I'm going to do it in 2 steps for you, square root of 9 over square root of 10. Everyone okay with that? And as a result, everyone, what is square root of 9? Ooh, square root of 9. Nice. It's just 3. So 3 over root 10. So it's just what I see here. I'm just trying to simplify as much as I possibly can. I do get a nice y over r as 3 over root 10. I would ask us, been doing this all semester here, rationalize denominators. So I am seeing that as the ratio. Looks good. So look at the algebra there. Go back, take a look and see. But I cleaned out that 5 in the bottom just by multiplying each of these 3 things by 5. Okay, on to the next, everybody. Cosine of theta over 2. Let's do that. One thing we have to do first. Is cosine going to be negative or positive in quadrant 2? It's going to be negative. So all the way through, guys, as you can see up here, all the way through, I kept a positive in front of the root. All the way for this one, guys, I'm going to include the negative in front of the root. So big negative, and this one is 1 plus cosine of theta over 2. All right, let's play it out, everyone. So negative goes with, I get 1 plus -4/5 over 2. Don't like the 5 as the denominator. Certainly want to deal with the fact that I have a fraction within the fraction. So what I'm going to do is multiply by 5, multiply by 5. Keep the negative in front of the root, and let's see what happens here. 5 times 1 is 5. 5's cancel here, and so plus a negative, so minus 4, and then over 2 times 5 is 10. See if you agree on that, and there comes the root to back it all up. Good. And let's see, it should work out nicely. Negative stays. I'm getting 5 minus 4, which is just 1, and then over the 10. So really the answer is negative square root of 1/10. Wouldn't mind cleaning it up just a touch there. And I hope everyone's okay with me doing this. You know, root 110, 1 over 10 I should say, is root 1 over root 10. And you know actually the square root of 1. Square root of 1 is just 1. So I get negative 1 over root 10. And by the way, guys, this would be the x to r right there. That's looking wonderful. X to r. But as I said, let's rationalize. And I'm hoping you would agree if you rationalize it, multiply the top and bottom by root 10. That's what you get. And there, everybody, is cosine of theta over 2. So every angle has the ratios that go with it. This is half of the original, and this would be the two ratios initially. All right, here's what I do for tangents. I just do my sine answer divided by my cosine answer. Now you could take the final product. If you do this over this, good things are going to happen. But you know, here really is your y to r. I'm just seeing it here is really your x to r. So if you decide to shortcut what I do here, you can definitely do that. But I'm going to go ahead and just, you know, final results, I guess. So 3 root 10 over 10 over negative root 10 over 10. Remember what happens here, everybody? The 10's cancel. Just wondering, would you see that the root 10's would cancel? And this would be a negative 1. So in reality, you end up getting a tangent ratio of negative 3. And that makes sense, guys. Take a look at my unsimplified version, which is, I would actually say is better now that I look at it. Y over r, x over r, so y over x, 3 over negative 1. Looks good. Okay, let me see if there's anything else to kind of put in place there. I would actually have us draw it. Why not? So go back just a little bit to the top there, letter B. Yikes. And if I take half of this, it brings us up here. I won't get the angle measures. I won't do that to you. But I'm just trying to see that should probably be up here, give or take. And the way I saw this drawn out, it's not great on my end, but whatever. So it looks like the y to r was 3 over root 10, and I already put the x in place. That would sort of be the ratio on the half angle. And again, we all know this squared and this squared equals that squared. Good. All righty, so let's just put in, just kind of looking at this, seeing if I need to tie up any loose ends for you. But that would be theta over 2 right there. All righty, so just be careful on this one piece. You have to find the quadrant first, then make sure you have either the positive or negative out in front. Okay, a lot of formulas obviously to work through in this unit. Let me know how I can assist you. Do those independent problems, of course, and help each other. That's the key. Well, thanks for listening. I certainly appreciate it.